Hello guys, in our last video, that is video 3, we have derived a formula to determine the active earth pressure based on Rankines theory. Now the beauty of the theory lies in the fact that it can be used to solve the problems even with the conditions which are not considered during the time of its development. For example, the backfill is loaded with surcharge, not free from surcharge. The backfill is submerged, not dry. The back of the wall is inclined, not vertical. And the top of the backfill is inclined, not horizontal. And moreover, if the backfill is cohesive, not cohesionless. So let us now see how the formula is used intelligently to solve the problems with conditions the formula was not originally made for.
Case 1. Let the case 1 be the original condition under which the theory has been developed. That is, the backfill is horizontal, the back of the wall is vertical, there is no surcharge above the backfill, and the soil is cohesionless and dry. Under this condition, if the soil is cohesionless, there will be some value of phi. So first Ka, the coefficient of active earth pressure, will be found as 1 minus sine phi by 1 plus sine phi. Now at any depth along the height of the wall, and at any point, the active earth pressure Pa will be given as Ka gamma D. D is the depth of the point. So it is noted that active earth pressure at any point along the face of the wall is nothing but the vertical pressure or load at that point multiplied with the coefficient of active earth pressure. This gamma D is the vertical pressure at that point. So at different point, gamma D changes. So Pa changes. At top, where D is equal to 0, Pa is equal to 0. At bottom, when D is equal to H, Pa will be K gamma H. Let the height is equal to H. So the stress distribution diagram, if it is drawn, it will be 0 at the top and K gamma H at the bottom. It is a triangular stress distribution diagram. Now, most often, this active earth pressure at times represented as a active thrust. There is capital Pa, which is a force acting at a single point. It is found as the integration of the pressure or simply the area of the triangular diagram. That is half Ka gamma H square. Then definitely the active earth thrust, capital P, will be acting at a single point. The point of action is required to determine. So we write it X at, so it is Y bar, it is H by 3 because CG of the triangle. So this is the Pa. So this is the formula in the original case. Now suppose case 2. Case 2, from the original condition, we deviate a little, we have to apply a surcharge. So backfill, case 2 will be backfill with uniform surcharge. So the diagram will be vertical wall as it was, horizontal backfill, but it carries a uniform surcharge of intensity, say K kilonewton per meter square. Now the Ka will be as usual 1 minus sine phi by 1 plus sine phi. The active earth pressure at any point will be again Ka multiplied with the vertical pressure. So vertical pressure at any point will be again gamma d plus Q. So we write not only gamma d but Q plus gamma d. This becomes our active earth pressure equation for the case when the backfill is loaded with uniform surcharge. So the diagram will be at top it will be d is equal to 0. So here Pa will be Ka Q not 0. At bottom it will be when d is equal to H, the active earth pressure will be K Q plus K gamma H. So at top it is not 0, it is something, and bottom it is a larger one. It is a diagram like this, trapezoidal diagram. To find the active thrust PA, we have to find the area of the diagram. To find the area of the diagram, generally what to do is, to make it convenient, we split it into two simple geometrical plane figures. So there is a rectangle and there is a triangle. So for triangle there is a P and for rectangle there is a P. So suppose this is P1, this is P2. The PA will be the sum of P1, P2. P1 plus P2, where P1 is equal to the area of the rectangular diagram, that is KQ into the height, and P2 is equal to area of the triangular diagram, that is half K gamma H square. Now the point of action of P1, P2 will be, P1 will be say Y1 is equal to H by 2. It is a rectangle, so Y1. That this is Y2. And Y2 will be H by 3. Now total active thrust PA is equal to P1 by P1 plus P2, and it acts at, suppose it is Y bar, final P1 Y1 plus P2 Y2 by the total of this one. This is the case. Now case 3. In this case, the backfill is submerged. So the retaining wall with horizontal backfill is submerged up to a height of H2 after a depth of H1 from the top. This is water table. Now because of this water table, H2 height of this backfill is submerged, and H1 height of the backfill is dry. Now the backfill consists of two layers, AB and BC. Layer AB is dry, hence the gamma of AB is gamma dry, and the gamma of BC will be gamma submerged. Now we will deal the problem layer wise. For the layer AB, for the layer AB, will here the equation of earth pressure will be, as it is dry, so original equation Ka gamma D, where D is within 0 to H1. D varies from 0 to H1 only. And the equation is applicable from A to B. At A, when D is equal to 0, equation gives you 0. At B, when D is equal to H1, the earth pressure according to the equation is Ka gamma H1. The pressure distribution diagram can be drawn from A to B as usual. This is 0, this is K gamma H1. The pressure distribution diagram from A to B is a triangular diagram. That's all. Now for BC, for the layer BC, D varies from 0 to H2. 0 to H2. And the layer AB now acts as a surcharge on BC. Layer AB acts as a surcharge on BC, such as Q is equal to, what is the quantity of surcharge? It is unit weight into total depth of the layer AB, H1. In that case, the equation becomes PA at any point below or between B and C will be Ka gamma H1 plus gamma sub D, gamma sub because this is the unit weight between B to C. In addition to this, there is water pressure also, horizontal water pressure gamma D, gamma WD. So at top, where D is equal to 0, D is equal to 0, the earth pressure is, this is 0, this is 0, only Ka gamma H1. At bottom, when D is equal to H2, Pa will be Ka gamma only Ka gamma H1 plus Ka gamma sub 3 H1 H2 H1 plus H2 plus gamma W H2. Now to find the total horizontal thrust PA, if we draw the stress distribution diagram, it will be in three parts. The first part is K gamma H1, then K gamma sub H2, the third one is gamma W H2. Gamma W H2, K gamma sub H2, this is K gamma H1. Now to find the total thrust, what to do is we read this diagram as consisting of three number of figures, 1, 2, 3, 4, and the area of each diagram represents the thrust for that particular diagram. So the total thrust is PA consists of P1 plus P2 plus P3 plus P4, where P1 is equal to the area of the first diagram, P2 is the area of the second diagram, P3 is the area of the third diagram, and P4 is the area of the fourth diagram. So finding area is not a problem. You can find this. And the point of action of the final thrust will be at Y bar from the base, which is found out as P1 Y1 plus P2 Y2 plus P3 Y3 plus P4 Y4 divided by sum of this P1, P2, P3, P4. This is how the total thrust and the point of action of the total thrust is found out at Y bar from the base. This Y1, Y2, Y3, Y4 are the heights of the point of action of individual areas, individual P1 from the base. That's all. So this is how we can find the total thrust and point of action when in the case of backfill with submerged backfill. Okay.
In this video, we saw how the Rankine's theory is extended to cover the problems with surcharged backfill and submerged backfill. In our coming video, we'll be discussing the problems with inclined back of the wall and inclined backfill. Okay, we'll see you then.